Hello everyone. In this video, let's learn about probability chapter 15. This is one of the easiest chapters in your textbook. There's just one simple formula and maybe 4 or 5 terms that you need to understand. And with that, you will be able to solve any question asked in your exam. So come on, let's begin. The theoretical probability, also called as classical probability of an event E, is written as P of E, and it is defined as number of outcomes favorable to event E divided by number of all possible outcomes. So this is the single formula that will be repeatedly used in all the questions, and you will be hearing the words event, outcome, favorable outcomes very often in this chapter. So let's discuss one by one with the help of an example. What is the probability of getting 3 when a die is thrown? The possible outcomes when a die is thrown are 1, 2, 3, 4, 5 or a 6. You might get any one of these numbers on a single throw of a die. So, number of all possible outcomes is 6. It's the count of all the possible outcomes. We have 6 different outcomes, so the number of possible outcomes is 6. Now, let E denote the event of getting 3 because we need to find the probability of getting 3. Let's choose getting 3 as event E. Then the number of outcomes that is favorable to event E is just 1. That is, only when this 3 appears, it is favorable to us. And only one side is marked with 3 dots. So number of favorable outcomes is only 1. So the formula for probability is number of outcomes favorable to the event divided by number of all possible outcomes. This is 1 and all possible outcomes is 6. So the probability of getting 3 is 1 by 6. Now, let's see what is the probability of getting an odd number when a die is thrown. The possible outcomes again when a die is thrown are the same 1, 2, 3, 4, 5 or a 6. So the number of all possible outcomes is 6. So the denominator is going to be the same 6. Let O denote the event of getting an odd number. So what are the odd numbers marked in a die? It will be 1, 3 and 5. So there are 3 different odd numbers. So the outcomes favorable to event O are 1, 3, 5 and the number of outcomes favorable to the event O are 3. It's the count 1, 2, 3 favorable scenarios or outcomes we have. So the probability of getting an odd number will be the number of favorable outcomes 3 divided by number of all possible outcomes, that is 6. Simplified gives half. The probability of an event is greater than or equal to 0 or lesser than or equal to 1. That is, probability is always greater than or equal to 0 and less than or equal to 1. Why? Because probability is number of favorable outcomes divided by number of all possible outcomes. The numerator, that is number of favorable outcomes, is always less than or equal to the number of all possible outcomes. So the numerator is always less than or equal to the denominator. Hence, this ratio will be less than or equal to 1 and it's always a positive value. Let's see what is an impossible event. For an impossible event, probability is 0. What is the probability of getting a number 8 in a single throw of a die? No face in a die is marked with 8. So this will never happen. Getting 8 is an impossible event. Favorable outcomes. The number of favorable outcomes is 0. Hence probability of getting 8 is 0. Sure or a certain event. For a sure or a certain event, the probability is 1. That is maximum. What is the probability of getting a number less than 8 in a single throw of a die? Every face in a die is marked with a number less than 8. So it is sure that we will always get a number that is less than 8 whenever a dice is thrown once. So the number of favorable outcomes is same as number of all possible outcomes, which is 6. So probability of getting a number less than 8 is 6 by 6 is 1. Every time you throw a dice, you will get a number which is either 1 or a 2 or a 3, 4, 5 or a 6. All these numbers are less than 8. So probability is 1. Complementary events. Let's consider two scenarios. Getting 3 and not getting 3 when a dice is thrown. If probability of getting 3 is denoted as P of E, then probability of not getting 3 is denoted as P of E bar. In both cases, the possible outcomes are 1 to 6. 1 to 6 here as well. So the number of possible outcomes is 6. Whenever a die is thrown once, the number of all possible outcomes is going to be same 6. Now in this scenario, favorable outcome is just getting a 3. So the number of favorable outcomes is 1. Probability of getting 3, P of E is 1 by 6. Whereas here, when we are considering not getting 3, the favorable outcomes are 1, 2, 4, 5, 6. Other than 3, all other outcomes. So how many favorable outcomes are there? 1, 2, 3, 4, 5. 5 is the number of favorable outcomes. So probability of not getting 3 is P of E bar 5 by 6. So these two events, getting 3 and not getting 3, are complementary to each other. E and E bar are complementary events. You can see that if we add the probability of these complementary events, you get 1. P of E and P of not E will give you 1. So P of E plus P of E bar is 1. So we can conclude that probability of E bar is 1 minus probability of E. So that is about complementary events. Now let's have a short recap of what we have learned so far. Probability of event E is number of favorable outcomes divided by number of all possible outcomes. Probability of E is always greater than or equal to 0 and less than or equal to 1. For an impossible event, probability is 0. For a sure or a certain event, probability will be 1. And probability of not E or probability of E bar is equal to 1 minus probability of E. E and E bar are complementary events. For MCQs from this chapter, please check out my next video. That's the end of the video. Thanks for watching and hope you liked it. Please subscribe to our channel and also press the bell icon to receive notifications as and when we upload new videos. Thank you and have a nice day.